students, in our previous video we are discussing about the topic in the chapter alcohols, phenols and ethers about the cleavage of OH bond. Cleavage of OH bond. There we have discussed that when an alcohol or phenol reacts with metal, what will happen. Now in this video we are going to discuss about the acidity of alcohol and also phenols. So let us take up the point, the acidity of alcohols first. Now alcohols are the group of atoms in which oxygen is having a single bond with hydrogen, and there are some group of atoms that is called R, means alkyl group. Let us take a very simplest example of the alcohol. OH is having a bond with carbon, that is having completely two hydrogens, three hydrogens around it. So when the oxygen is bonded to a single carbon, we can call it as a primary alcohol. Now I am replacing one of the hydrogen with some other carbon chain. The main thing is, when the oxygen is directly bonded to only one carbon in the alcohol, such kind of alcohols we call them as the primary alcohol. We call them as the primary alcohol. Yes. Let us see, does alcohols have acidic nature? Okay. What are the atoms we can find here? We can find the atoms here, the hydrogen, oxygen and carbon. Let us take their electronegativity values first. Hydrogen electronegativity value is 2.2, oxygen electronegativity is 3.4 and carbon electronegativity is 2.5. Now once we study the electronegativity values, it will be very easy for us which is withdrawing electrons towards to it in the bonded atoms. Now let us see, oxygen being the highly electronegative element of 3.4, it is going to withdraw the electrons from hydrogen, the least electronegative element among these three atoms, and also the carbon, which is having 2.5, very less than the 3.4 of oxygen. So oxygen is readily withdrawing the hydrogen electrons, we had already discussed. So we came to know there is a cleavage between oxygen and hydrogen bond. But the oxygen withdraws the electrons from the carbon also, because carbon electronegativity is only 2.5, lesser than the oxygen. Hence, we can find the two areas that oxygen is withdrawing electrons from hydrogen and also carbon. But when we compare, the hydrogen can be easily lost here due to its least electronegativity. The completely bond will be withdrawn toward the oxygen. Means hydrogen will be given out in the form of H+. Hydrogen is given out in the form of the H+. But one notable thing is, the carbon, when it is losing electrons towards oxygen, there is another group of atoms that is bonded to carbon. So these group of atoms, if you remember, if it is an ethyl group, like C2H5, or if it is an methyl group like CH3, we had learned in our first year that these group of atoms will show plus I effect. Which effect do they will show? Plus I effect, means they will donate the electrons to the bonded atoms. So the methyl or ethyl, here when the R is the methyl or ethyl, they are donating electrons to the carbon and return carbon giving electrons to the oxygen. Now what do the oxygen will do means, it will not withdraw the electrons from hydrogen. In which case, when the alcohol is a primary alcohol, means when the carbon is bonded to an methyl or ethyl. Now it is not withdrawing electrons from hydrogen like the previous case. Its acidic nature is decreasing. Whose acidic nature is decreasing? The primary alcohol acidic nature decreases. Acidic nature decreases. Why does the acidic nature decreases? Because there are some group of atoms that are donating electrons to the carbon. In return, oxygen is getting the electrons. So its acidic nature is decreasing. The key point is when does the acidic nature decreases? Acidic nature decreases when the number of alkyl groups increases. When the number of alkyl groups increases. So this is the main point tonight. Acidic nature decreases when the number of alkyl groups increases. We know there are three kinds of alcohols. Primary alcohol is the one in which carbon is bonded to only one alkyl group. Secondary alcohol is the one in which carbon is bonded to two other alkyl groups. This is an secondary alcohol. And the next case is the one in which carbon is bonded to three other alkyl groups. This is called as the tertiary alcohol. So let us write the order in which there will be least acidic nature. See the condition. Acidic nature decreases when the number of alkyl groups increases. In which case more number of alkyl groups are present. Tertiary alcohols we have three alkyl groups. So there are three donating groups. Acid is the least acidic. So when we want to write the acidic order, in alcohol, what shall we write? Primary are more acidic than secondary, which are more acidic than tertiary. The acidic order in alcohols we can write as primary are more acidic than secondary and tertiary, because the number of alkyl groups increases, the plus sign effect increases. So let us take the acidic nature of alcohols order. Now let us see what will happen when the H plus ion is given out. In the case of primary alcohols we discussed, it is highly acidic. When the H plus ion is given up, what will happen? Let us see here. So we had already discussed that primary alcohols are highly acidic in nature. Means their bond is going to be taken up by the oxygen. So what is going to be formed? They are going to form an alkoxide ion. They are going to form an alkoxide ion. Now let us compare which is more acidic, alcohol or water. What is our comparison now? Which is more acidic, alcohol or water? In case of acidic nature, which is more acidic, alcohol or water? Yes, what is the reason we need to study means there is a lot of reason here. When an alkoxide ion we observe, when this was added to water, the water we know HNOH. Here it readily gives one H plus ion. Which is readily giving one H plus ion? Water is readily giving one H plus ion, and alkoxide ion is accepting the H plus ion. Whatever donates the H plus ion, we can say that is acidic or acid, and whatever is accepting the H plus ion, that is called as the base. So this is accepting the H plus ion, and water is giving up the H plus ion. Water is giving the H plus ion. So we speak this is acidic, whereas this is having basic in nature. So what are they forming? They are forming now RCH2OH conjugated acid. In the first year we have already learned conjugated acids are the one which accepts the proton ion. This side accepts the proton ion. Now it is, we can call as the conjugated base. We can call this as the conjugated base. We can call this as the conjugated base. So now which had readily given the H plus ion means we say water had given readily the H plus ion. So who is accepting H plus ion? Alkoxide accepting the H plus ion. So we say these alkoxide ions are having basic nature. When we compare the alkoxide ions with sodium hydroxide, what we say is these alkoxide ions have more basic nature than sodium hydroxide ion, because what we have discussed is in the previous case a hydroxide ion is there and alkoxide ion is there. When we have used water, this alkoxide ion is readily accepting the H plus ion. Similarly, when you take sodium hydroxide, there also hydroxide ion will be generated. Instead of that hydroxide ion, the alkoxide ions are readily accepting the H plus ions. So these are stronger bases. Alkoxide ions are stronger bases. Let us take now the acidity of phenols. Now let us take the acidity in phenols. This is very important for the objective children than the acidity in alcohols. So let us concentrate here much the acidity in phenols. First and foremost thing is phenol plus sodium metal. Do we know the reaction there? Phenol when reacted with a sodium metal, it is able to displace, sodium is able to displace the hydrogen ion there, and it is going to form a sodium phenoxide ion, as usually hydrogen gas used to be released. For that we used to balance the reaction. So here what was formed? Sodium phenoxide ion was formed. Because point here is phenol had readily given the H plus ion. The same thing had happened with ethyl alcohol also. Ethyl alcohol has also reacted with sodium. It had also formed sodium ethoxide. But the another main comparison is phenol reacts with aqueous sodium hydroxide. With what is reacting with? Aqueous sodium hydroxide. This aqueous sodium hydroxide nature is base. Nature is base. So the phenol is going to react with the sodium hydroxide. Sodium is going to displace the hydrogen. Correct. But the remaining product is water here. Here also the main product is sodium phenoxide ion and also water. We got the same sodium phenoxide ion. Ethanol did not react with sodium hydroxide, but phenol reacted with the sodium hydroxide. So we say this is a base, whereas this is an acid. Hence we say phenol is more acidic. Phenol is more acidic than ethanol. Phenol is more acidic than ethanol. But this is not enough. We want to give you a clear data. The phenol, once we study clearly, in the benzene, we had the alternative double bonds, and the OH is attached to a carbon whose hybridization is sp2 hybridized carbon. It is an sp2 hybridized carbon. Let us compare with any of the alcohol. In the case of alcohol, the OH is bonded to a carbon that is of sp3. But here, what is the hybridization of carbon? Hybridization of carbon is sp2. We already learned the hybridization of sp2. It is more acidic than sp3. Hybridization of sp2 is more acidic than sp3. Hence, we conclude a point. The benzene ring will start withdrawing the lone pairs of oxygen towards to it. Who is withdrawing the lone pairs? Benzene ring is withdrawing the lone pairs of oxygen towards to it due to the acidic nature of sp2 hybridized carbon, which is more acidic than sp3 carbon. Now, we go on forming the resonating structures that we had discussed in the first year. Whenever there are more resonating structures for any molecule, it will have more stability. It will have more stability. When there is more stability, it is having more acidic nature. It is having more acidic nature. Do you remember the resonating structures of first year? Let us recall ortho, meta, para positions. Here it is called meta and ortho dash. Good. Now, when the lone pair was in conjugation, the pi bond moves on to the ortho position, resulting a negative charge at ortho position, new double bond between oxygen and benzene ring. On the oxygen we got a positive charge also. The negative charge that is developed at ortho position will be further involved in resonance, forming a new double bond and a negative charge. Again, the negative charge comes back into resonance. At last, it will be migrating the pi bond onto the oxygen. From here to here, there are three resonating structures we can find. Now, please observe, when the resonating structures are increasing, what will happen? Stability will be increasing, and that will make the compound more acidic when there is more stable nature. But do you find any resonating structures in the case of alcohols? We do not find any resonating structures in the case of alcohols. We find resonating structures only in the case of phenols. Hence, due to the presence of sp2 hybridized carbon and resonating structures in phenols, they are more acidic. Than alcohols. They are more acidic than alcohols. These are the two key points to learn, due to sp2 hybridized carbon and due to the resonating structures that are present in phenol. Phenols are more acidic than the alcohols. Now let us see how does the acidic nature of phenol will increase when there is a disubstitution in phenol. Because we had learned in the first year on the benzene, when any group of atoms are present, it is just called as a monosubstitution. And now we got the OH group on the benzene, so already monosubstitution is completed. Now there is going to be another substitution on the benzene. Of the phenol, we give a disubstitution. Now we depend upon the group of atoms that are bonded to this phenol, which will increase acidic nature or that will decrease the acidic nature. We will come across now. Let us see now the acidic nature in phenols. Here there are two main points. Once we recall our grade +1, that is first year, when any donating group is present on the benzene ring, it will donate the electrons to the benzene ring. So migration of the pi bond takes place, resulting in the resonating structures. Where are the negative charges we observe when donating groups are present? We observe negative charges at the ortho position, para position and ortho dash position. When the electron donating groups are present, the negative charge increases on benzene at ortho, para and ortho dash. At that point where we have negative charge, we can add one electrophile because this is acting like a nucleophile now. Do you remember nitration of benzene? It can be achieved by mixing HNO3 with H2SO4, the nitration mixture, that will generate an nitronium ion. The nitronium ion NO2 plus, it is the strongest minus R group. Which group? Minus R group. Once you recall the first year topic, minus R groups that are present on benzene, which will create a negative resonating effect. The NO2 is the best one. NO2 is the best one. Means, let us take the concept, whenever we have a phenol, we have already discussed in the phenol the resonating structures. When we are studied the resonating structures, negative charges are present at ortho and para position, including ortho dash. Now let us speak when phenol is reacted with the nitration mixture, or especially when we react only with dilute nitric acid. When phenol is reacted with only dilute nitric acid, we can get two kinds of products. One is called orthonitrophenol. What is the first one called? Orthonitrophenol. And another one is called paranitrophenol. 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 What is the nature of NO2 group, children? NO2 is an electron withdrawing group. NO2 is the best electron withdrawing group. Now this NO2 is withdrawing electron towards it. Means benzene ring is immediately withdrawing electrons from the oxygen, and the oxygen in return readily withdrawing electrons from the hydrogen. Means due to the presence of an electron withdrawing group at NO2 at ortho position, phenol, that is orthonitrophenol, can readily lose the H plus ion than the normal phenol. The substituted phenol, that is orthonitrophenol, is now readily losing the H plus ion. Means when it is readily losing the H plus ion, can we say it is more acidic? Yes, it is. Acidic nature is increased. Let us take up the next one. That is when nitro group is in para position. Here also it is withdrawing from benzene ring, and in return due to the dislocation effect or resonating effect, the final step, oxygen will be giving up its lone pair to the benzene ring. In return again, oxygen need to withdraw electrons from hydrogen. So the presence of nitro group at ortho position and para position on the phenol is increasing its acidic nature. So when does the acidic nature of phenol will increase? The acidic nature of phenol will increase when there are electron withdrawing groups at ortho position and para position. When the electron withdrawing groups are present at ortho and para position on phenol, its acidic nature increases. Its acidic nature increases. That's we are given a definition. Groups that increases acidic nature of phenols. What are the groups that are increasing acidic nature of phenols? Electron withdrawing groups at ortho and para positions on phenol increases acidic nature. Generally, the acidic nature of phenols or any carboxylic acids will be expressed in the pKa values. How are they expressed as the pKa values? Means the acid dissociation constant. Acid dissociation constant. Acid dissociation constant. Here, the main point is higher the pKa value, least will be its acidic nature. Least will be its acidic nature. Higher the value, least will be its acidic nature. Means when the value is increasing of the pKa, acidic nature is going to decrease. So keep this point in mind about the pKa values. We will have a detailed description about pKa values later. But the point you must come across is higher the pKa value, least will be the acidic nature. But before we get the values, keep in mind when electron donating groups are present, acidic nature is going to be decreased. Now up to now I had explained about electron withdrawing groups. Now the point what I am giving is when electron donating groups are present, there the phenol acidic nature is going to decrease. So let us say the point now, when the electron donating groups increases on the phenol, its acidic nature decreases. The point that we are given is the electron donating groups at ortho and para positions on phenol decrease the acidic nature. We had already discussed the acidic nature is explained in the pKa values. Once we see the normal phenol, its pKa value is only 10. What is the pKa value of phenol? Only 10. But once we see the para-nitrophenol, its pKa value is 7.1. Means when the electron withdrawing group is present, the value falls less than the 10. Means lesser the value, more is the acidity. The ortho-nitrophenol is having the value of 7.2. Means it is also more acidic than phenol. But we explained that when electron withdrawing groups are present in ortho and para only, the acidic nature will be increasing more. In the case of meta-nitrophenol, its effect is less when compared to ortho and para. Its pKa value is only 8.3. So what we speak is, according to the previous topic, when the electron withdrawing groups are present, the pKa value is decreasing of the phenol, means its acidic nature is increasing. But the present topic is when electron donating groups are increasing or present, what happens for the pKa value? We know methyl group when present on benzene, that will show plus R effect. Which effect is it showing? Plus R effect, positive resonating effect, because it is an electron donating group. Electron donating group. These electron donating groups decreases the, when they are giving the electrons to benzene, again benzene will give the electrons to oxygen, and oxygen is not ready to take up the electrons from hydrogen, so its acidic nature is decreasing when the electron donor groups are present. So we can see the compounds like orthocresol. And the IUPAC naming we had already discussed about cresol. Orthocresol, paracresol and metacresol, they have the pK values of 10.1, 10.2, 10.2. Means what we say is their pK value is lesser than our normal phenol. Lesser means when the pK value is going on to the highest position, its acidic nature is decreasing. So when the electron dating groups are increasing or present, the acidic nature of phenol decreases. Let us compare now the acidic nature of phenol with ethyl alcohol with respect of the pK value. The pK value of phenol we came to it is 10, but with ethanol it is 15.9. How much it is around? 15.9. The higher the pK value, least will be the acidic. Ethanol does not have any sp2 hybridized carbon and it does not involve in resonance. So its pK value is very high, it is 15.9. So we speak phenols are more acidic than alcohols. Phenols are more acidic than alcohols. In our next video we will discuss about the cleavage of OH and the esterification of the